Hello everyone, I'm Sergio Silento and continuing with the how to do videos created by CMG. In this opportunity, we are going to observe the new options to create planar hydraulic fracture using the new Builder's Wizard. In this exercise, we are going to start from an already created model for shale gas, where we are going to create 4 vertical planar fractures in the horizontal section of the well. Here we can see the model. The model has a very low permeability around 1e-4 millidarcy. The first thing that we must do is go to wells and recurrent section and select hydraulic fracturing option. As you can see, we have only one well. If there were more wells, they would appear here, and you would have to select which one will be fractured. In this screen, you can create new dates for the fracture treatment, and it is possible to load fracture file already created in the following format: CMG frac, or an gslib. This file have all the information of spacing between fracture and stages, number of fracture, number of stages, etc. To create the 4 planar fracture for the well 1, the first thing we need to do is click on the date below the well to activate the different options to create hydraulic fracture. In the options tab, since we are working with a gas model, we are going to activate the non-Darcy flow option, okay? Where we will use a general correlation. To activate, go to flow correlation option and select general correlation. And we will leave all the default values in order to the correlation correct the production of the gas, water, and oil. After that, click in OK. In Apply. And go to Fracture tabs. Okay. We can see 3 formats to load fracture data. First, the planar fracture. The second one, the complex fracture. And finally, import fracture data from third-party software. For this exercise, click on New Planar Fracture Stage. A new land fracture will be added to the selected well. Click on Edit button next to Fracture Template in order to create a new template. Okay. On this tab, you can create many templates as you want. For this exercise, we will create one template. In the name section, you can change the name of template. In this case, we use a default name, Planar Template. For primary width, we can use the value of 0.001. In fracture permeability, expand the option, click in 3 dots box, As you can see, new option of bidirectional permeability gradient. Here we have a horizontal direction and vertical direction. Another new option that we can see is that we can change the shape of the fracture to elliptical. We will see this option later. For intrinsic permeability, set the value of 10,000. And now, the new bidirectional gradient option allowed to set for the horizontal and vertical direction a linear or exponential declination from the center of the fracture to the tip in each direction. Okay? In the horizontal direction, set in the decline method linear decline. If you expand the option, you can see the exponential decline. But in this case, set linear decline. And put in tip permeability value 5,000 millidarcy. And as you can see, the wizard calculates the effective permeability considering the fracture width, intrinsic permeability, and cell width, obtaining the value at the center of the fracture of 5 millidarcy and 2.5 at the tip of the fracture with a linear declination. If you want, you can change the declination for, in this case, for exponential decline. And now, in vertical direction, set decline, linear decline, and the value of the tip permeability is 1000 millidarcy. And you can see the effective permeability at the tip will be 0.5. Click on OK. In secondary permeability or secondary fracture, for this option, do not enter values. The secondary fracture values apply in dual permeability reservoirs in the region surrounding the hydraulic fracture. This natural fracture may also have been stimulated by the hydraulic fracture entrainment. The resulting permeability is typically much less than fracture but higher than matrix. This stimulated region around the fracture will be included later. Continue with options. For orientation, as the well was drilled in I direction, the fracture will be created perpendicular to that direction. For this reason, select J value or J direction. For number of refinement, as mentioned before, the local refinement is performed on the fracture cells to better represent the fracture thickness and reduce convergence problems. Set 7 refinements in I direction, 7 in J direction, and 1 in K direction. In fracture half length, this parameter represents the length of the fracture on both sides of the wall. If a single value is left, the fracture will have the same length on both sides. While if two different values are placed, different length will be observed on both sides. For this exercise will be include two values: 350 space 200. Okay, 350 feet for one side and 200 feet for the other side. For vertical extension of the fracture, it can be placed two ways. Okay, one, placing the number of cells up or cells or layer down, or expand the option, we can place in the height or depth. Okay, for this option or for this exercise, select use height and up down, and place for height, for frac height, 150 feet, and for fracture depth, place 180 feet. Leave a grid cell width of 2 feet, and finally we can create connections between fracture in the same well or fracture of neighboring wells. In this case, we leave this option by default. Clicking Apply button and move to Fractures tab. In Fracture Template, select the template that we just created, Planar Template, and now we are going to select where it is going to be fractured, leaving the all perforated layers. All the perforated cells of the well will be fractured, but if we select MD slab values under well settings section, desired depth or cells can be perforated. Okay, activate this option, MD slab value, and select IJ slab. And the cells that that will fracture will be 22 space 28 space 34 and 40. Click and apply and OK. As you can see, the fracture in the 4 fractures were created. If we move to layer 5, here is the horizontal section of the well, and the 4 planar fractures were created perpendicular to horizontal well section. As you can see, this side is shorter than the other side because remember we place 35 in this direction and 3500 and 200 for this direction. If we we make a zoom and move to permeability property, okay, we can see that we have in the center of the fracture we have 5 millidarcy, and at the tip we have 2.5 millidarcies. Okay. if we change the viewing plane to JK2D X section, and now move to cells 28, okay, sorry, okay, move to 28 cells. Okay, we can see the degradation also in vertical direction and horizontal direction with two different degradation. Okay, 5 millidarcy at the center, and in horizontal direction we have 2.5 on the tip and 0.5 in vertical direction at the tip. Now we are going to see how to create different properties for the fracture and for the stimulated zone around the fracture. The flow behavior inside a hydraulic fracture will be different than in the matrix. In this case, we will provide a new relative permeability set for the fracture, increase the water saturation in the fracture, and increase permeability in the stimulated zone near the fracture. To do this, go to rock fluid section and double-click in rock fluid types. Then click on black arrow in order to create a new rock type for the fracture. Deactivate capillary pressure options and type for water oil table, type 0.01, 0.99, 1010, a segregated curve. Click and apply. Move to liquid gas table. Again, deactivate capillary pressure options and type 0.02, 0.02, 0.98, 0.101. Click and apply and OK, and now you can see the segregated curve for the fracture, for liquid gas curve, and for oil water curve. And now we're going to set the number of relative permeability set number in order to apply one for the fracture and one for the matrix. Move to reservoir option, click on specify property, go to rel perf set number, okay, type 1 for the matrix, and in rel per set number for fracture, type 2. What is the meaning of that? The relative permeability number 1 is for matrix, and number 2, the new one, is for the fracture. Now move to initial water saturation, and the same for initial water saturation is the initial water saturation for matrix type 0.2 and initial water saturation for fracture type 0.01. Click OK twice in order to apply the changes. And now go to Wells and Recurrent section and click again on hydraulic fracturing, double click, move to templates tab, and include here in additional property definition, click twice on green plus sign in order to add two properties. Okay, the first property will be initial water saturation for fracture zone will be 80%, 0.8. This water saturation overrides the water saturation that we include before, and for fracture, set relative permeability set number and number 2 for the fracture. Okay, click apply, and now include 3 another properties. Click 3 times on green plus sign on 1, 2, 3, and select permeability I, horizontal permeability, and type 0.1 for stimulated zone. Okay, no fracture zone is the same that a stimulated zone is are cells around fracture. Remember, this permeability will be less than fracture permeability and higher than matrix permeability. Select permeability in J and permeability in K and type the same value, 0.1. Clicking apply, and now go to fracture permeability, expand the option, and select or activate the create elliptical fracture in order to see the changes on the shape of the fracture. Change the decline method for horizontal direction from linear decline to exponential decline. The same procedure to vertical direction, change linear decline to exponential decline, and change the value for 1000 on the tip. Clicking OK, apply, click yes, and OK, and move to permeability. Okay, as you can see, the shape of the fracture changes. Okay, and if we go to permeability change the viewing to aerial, and change the scale to logarithmic scale, and as you can see, we have the fracture permeability in red, in green the stimulated zone around the fracture, and in blue the permeability of the matrix. With this, we finish with the video on how to create planar fracture using the new wizard in Builder, and we invite you to continue consulting the how to do videos in our YouTube channel, and see you later. Thanks.